We are going to look at percentage yield in this video, and when you do this, it's important to don't confuse this with percentage atom economy. It's a different thing. There's a separate video about atom economy, but I'm not going to talk about that now, but don't confuse the two. Okay, so percentage yield is simply this. It's when you do a chemical reaction, it's you put the mass you obtain divided by the mass you expect to get multiplied by 100. So if you expected to get 10 grams and you only get 5, that'd be 5 over 10 times 100. That'd be a 50% yield, which makes sense. Yeah. Okay, so that's what we're going to do. It's pretty easy calculations. So let's say, take this reaction as an example. Sodium reacting with chlorine to make sodium chloride here. And we start off with 3 grams of sodium. Now, if you did that, started off with 3 grams of sodium, you would expect to get 7.6 grams of sodium chloride. And we won't talk about how you know that just now, but we will later on in the video. But basically, to work out the expected amount, you need to do a reacting mass calculation, which is a separate video, but I will cover it in this one as well. You need to do that, but do that later on. So let's just work out the percentage yield here then. Percentage yield, well, we expect to get 7.6 grams, so that goes on the bottom, but let's say we obtain, let's say we've only obtained 5.1 grams. So the amount we do get is 5.1 over 7.6 multiplied by 100. So in that case, we will have got a yield of 67%. In that experiment, we will have 67% yield. Now, because we only got 5.1 grams and we were expecting to get 7.6 grams. Right, now you never get 100% yield, and you might be asked why you don't get 100% yield. And there are a few reasons. Let's talk about them. Right, number one, you can say not all of the reactants reacted. So not all of it reacted. In this case, it's sodium. So when your answer, be precise. Don't just say, or reactant, say not all the sodium reacted. Which is perfectly possible. You might be under with a bit of sodium metal that hasn't reacted with the chlorine. Okay, then if I had to give another reason, the next best one after that I would say is, well, perhaps the sodium that you got was not pure. So the sodium wasn't pure. Or more generally, the reactants not pure. And finally, if I was to say another one, this one will depend on the type of reaction, whether you're making a solid, a liquid, or a gas. It will depend. But say some of the product escaped. In this case, escaped the container. Okay, so in this case, it's sodium chloride, which is will be produced as a smoke, and so it quite easily escape from the container in that case. So they usually only ask for 2 reasons, so any 2 of those 3 will be good enough. Right, just before we finish, let's just recap on how we would know what is the expected amount. And that, as I said a minute ago, is we do a reacting mass calculation, which is subject to another video. So let's do a reacting mass calculation here. Right, so we're going to need our usual formula. Moles is equal to mass over mR. We're going to use that. Okay, so what we know from this equation tells us that 2 moles of sodium chloride, not worried about the chlorine, gives us 2 moles of sodium gives us 2 moles of sodium chloride. So we can simplify that. We can say that 1 mole of sodium will give us 1 mole of sodium chloride, a nice easy ratio. Okay, so how many moles of sodium have we got? Well, we don't know how many moles, but we do know the mass. We've got 3 grams, okay? So let's do that. Moles of sodium is equal to the mass, which is 3 grams, divided by the MR, really the AR of sodium, which is 23. And that is equal to 0.13 moles. Okay, so 0.1 mole of sodium, because this is 1 mole of sodium chloride. So 0.13 moles of it will give us 0.13 moles of sodium chloride. Now, what's the mass of 0.13 moles of sodium chloride? Well, we've got to rearrange our equation up here. So we know that mass of sodium chloride is equal to the moles multiplied by the MR of sodium chloride. So that's equal to 0.13 multiplied by MR of sodium chloride is 23 for sodium, 35.5 for chlorine, so it's 58.5. Do that, the answer is 7.6 grams, which is our amount there. Okay, so that's how we do the reacting mass. So a good bit of revision for reacting mass calculations there. But really, the basic percentage yield calculation is very easy. You've just got to put the numbers into that equation. Right, if you want a bit of practice, down here, there are 3 examples. Okay, make that a bit smaller so you can see it. 1 minute. Okay, so you've got those reactions. So you've got number 1, iron oxide forming iron, reduced by carbon monoxide. Start off with 80 grams, you get 45 grams of iron. That's the percentage yield. This one, magnesium nitrate, number 2, is a solid. You heat it up and you get given this brown gas, nitrogen dioxide is given off. And that's the product we want. So starting with 25 grams of magnesium nitrate, you get 11.1 grams of nitrogen dioxide. What's the percentage yield? And then this one, the final one, this is a cracking reaction. So you've got a longer hydrocarbon, C10H22. You break it down into alkenes and an alkane. Right, starting, and you want the alkene as a product. So 150 grams of C10H22, and you get 118 grams of ethene, C2H4. What's the percentage yield? Okay, so you can check your answers with those.